Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this find whether path exists problem of a GFG. So let's move on to the problem guys. So guys, here we are given a matrix of size n into n. Okay, and the each block of a matrix means each I comma jth column or block contain any of the four values 0, 1, 2 and 3. Okay, like and exactly one cell will contain one, exactly one cell will contain two, and as many as cell can contain three as well as zero. Now if a cell is one, it means it is our source, means starting point. Okay, what I want to write means starting point. If I want to, then means it is our destination, or this is our end point. Okay, so we have to start our traversing from 1 and go up to 0, but there is one condition. Each block in which we are moving should contain only 3, should contain value 3, because 0 means wall here. So in 0 we cannot move in 0. Here 0 means wall and we cannot walk through a wall. Okay, so there is one condition. We have to traverse from 1 to 2 with all blocks having 0. If it is possible, then we just return 1. 1 means yes, we have a path. Else while we will return 0 means no path. So here you can see this is our source, this is our destination. So from 1 we can move in any four direction. Up up means I minus nth column, I minus nth row. Down means I plus nth row. Right right means j plus nth column means next column. Left means 1 before column means j minus 1. Okay, means j minus 1. So here from 1, we can go to 0, we can go to 0, we can go to 3. Now we, as you know, from 1 we can go to there, but we cannot move through 0 because 0 is a wall. So this is a blockage, here is a blockage, but we can go to 3. Now from 3 we cannot move further because it is 0 and it is 1. So again we are moving in a cycle, doesn't matter. Okay, so we can never be able to go to 2, so that's why we will return 0. Meanwhile here, this is the path which I can follow, that is marked by red color, 1, 3 and 2. Okay, you can either follow 1 then 3 and 2. Okay, so guys, now how we will solve the path. So first of all I just copied everything. Okay, okay guys, so we are at here, we are at 1, then we are at 2. So basically we will maintain two matrix. This is our read matrix, given matrix, and one matrix we make dp. Why dp? We will make dp of same size as of this. We will make same size and we will start it will all are 0. Okay, size are equal. Okay, all are 0. I just make this much matrix for my convenience. Here two more blocks. Okay, you can build as here is one, here is one. So initially all are 0, but I will mark it as 0 initially, but then I will mark it as 1. Why 1? Because here is 0 means it is my starting point. So I mark it 1. 1 means I have traversed from this particular block, means I have already moved from this particular block, and from this one we can go to this. So I will mark it 1. Now again I go to there, then again go to there, then this will make a cycle and give me an infinite loop that will never end. That's why I will mark with 1. One block means I had already moved from this particular block. So here I found a way or not. So here has not any mean from moving again and again from same block. Okay, so that's why I just mark it that TP vector or TP 2D dynamic programming array, TP array. Okay, you can say. So guys, how we will do it? From one we will start to traverse in all four or in all four direction. Which four direction? In x plus I, this is x comma y, this is x comma y. In x plus y I will add I will add I, here I will add j, I will add. Now what can be possible? 0 comma 1, 0 comma minus 1, 1 comma 0, minus 1 comma 0. This is minus 1. Now 0 comma 1 means from 0 to next column means right. 0 comma 1 means right. 0 comma minus 1, 1 before column means left move. Now 1 comma 0 means in next row means down, means down. Then minus 1 comma 0 is up, upside means above the row. Okay. So I will do x plus 0, y plus 1, x plus 0, y minus 1, x plus 1, y plus 0, y minus 1, x minus 1, y 0. So these are the four. Okay. And here is one more condition. One more condition I will check for moving. From my x comma y, I will try to move in all these four directions. But there is one condition. There is a condition. My dp of x dash, that means my new x and new y dash should be is equal to 0, means they have not moved yet. Like here I can move, but I cannot move here, I cannot move here. And one more condition, and one more condition, my x dash and y dash is valid. This is first. Valid means x should be within 0 to n minus 1, 0 to n minus 1, and n is the size of the rows, and y should be within 0 to m minus 1, 0 to m minus 1, 0 to m minus 1. This is my row, the row and column limit. And my dp x dash comma y dash should be is equal to 0, means I had not moved from this block yet. And one more condition. What is the condition? My grid means the block in which I am moving, my grid x dash comma y dash should be is equal to 3, should be is equal to 3. Why 3? Should not is equal to 0, should not is equal to 0. I am telling you why. Should not is equal to 0. Not is equal to 0 means it can be 2, it can be 1, it can be 2, and it can be 3. If it can be 3, I will move. Okay. If it can be 2, means we had got our answer. In next move I will see my x coordinate of my destination is equal to my current x and y coordinate. Then I will return true, means I have found. Okay. And in one if my create x dash y dash is equal to 1, then you can see I mark dp x comma y where grid xy is as 1, where what I am saying, this index I already mark as 1. So if my grid xy is 1, then I will never be moved because my dp x dash comma y dash is never be equal to 0. This condition false. Okay. So here all the three condition I can write, but here is one condition, my grid should not is equal to 0 because I cannot move through a wall. This is a basic case that I want to check. Now let's I show you the code. N is the number of rows, m is the number of columns. Now I will check vector of int dp of size n comma f and initialize all with 0. Then I will take four variables x comma y means the starting coordinate of my source. Then sx comma sy as -1 means that's the coordinate of my destination, the coordinate of my destination. Okay. Then I will run a for loop on the complete uh, given grid. If my grid ij is equal to 1 means I have found my source coordinate, so x is equal to y is equal to j. And if my grid ij is equal to 2 means I found my destination coordinate, so destination x coordinate I and destination y coordinate as j. Now within this for j loop, if my x is not is equal to 1 and my destination of x is not is equal to 1, it means I found my source as well as my destination. Okay. If I found both, then I don't need to traverse further loop, so I will just break. Now in my this for loop, what I will check if my x is not is equal to 1 and the coordinate of my destination x is not is equal to 1 because I initialize all of them as -1, means I have found them. Then I just do break and I am out of the loop. Why? Suppose we are given a 100 into 100 size, 100 into 100 size, 100 size grid. Okay. 100 into 100. So time complexity for turning this is 10 raised to the power 4 because this is I into j. Okay. I is 100, j is there. And suppose it is given as this is 1 and this is 2. So okay, for I is equal to 0 and j is equal to 0, we found our 1. For I is equal to 0, j is equal to 1, we found our 2. Okay, so we don't need to traverse in this row as well as in further rows. So we just come out of the loop, come out of the loop. So you can see my 10 raised to the power 4 complexity will decrease to O2. O2 means constant. That is, you can say on O1 means only two step you need to do. So O1. So O10 raised to the power 4 just come out to O1. Okay, that's why you don't need to further do a loop if you found x and means source and destination coordinate. This one is for jth loop, this one is for ith loop means row and jth. Then I will mark my source coordinate means x and y as 1. Then I will return dfs. Return dfs means this is a function that will give me 0 or 1 depending on whether I found the route from 1 to 2 or not. Now what I am passing in it, x and y, my coordinate of my current node, then n comma m, the coordinate of my grid, then grid. Okay, then my dp, these are two vector, then coordinate of my destination x and y. Now here is the dfs. Now all the same thing, you can see I am taken. Now if my source coordinate or the coordinate of my current node is equal to x coordinate is equal to destination x coordinate, and y coordinate means destination y coordinate, it means both of them are equal. So the current node is my destination node, so I will return 1 means I had found a node, so I just need to return. Now for I is equal to 0 to I less than 4. Why 4? Because from 0 to 4 I have 4 direction: 0, 1, 2, 3. So from 0 to 3 indexing I can check for all 4 direction. Now what is 4 direction? I am taken two vector dx and dy. So here you can see dxi comma dxy will make a one direction, like 1 comma 0 minus 1 comma 0, 0 comma 1 and 0 comma minus 1. Okay, so I will take temp x and temp y. Temp x is equal to x plus dxi, y plus dyi. Now I will check is valid dx temp x and temp y, means the new coordinate should be valid, means it should be in the limit of my grid. Now what is it is valid? Xy. My x coordinates should be greater than is equal to 0 and should be less than n, and as well as my y coordinate also should be greater than is equal to 0 and less than m. Okay, this is if these both are valid. Then my grid, here I am taken grid as g. Grid as only g because I don't declare any variable named as g, so I can mark grid as g. Now my g temp x comma temp y means my new variable, my new block should be not is equal to 0. It not contain 0 because 0 means wall and I cannot move through a wall. So if it is not is equal to 0 means I can walk through it. And the third condition is my dp of new x comma y coordinate mean temp x comma temp y should be is equal to 0, means I had not moved from this particular index yet. Okay, then I will mark dp of temp x comma temp y as 1, means I had marked through this uh, particular index I comma j, I mean temp x comma temp y, or you can say. Then I will say if my dfs, if dfs temp x comma temp y are my new updated source coordinate now. Okay, temp x and temp y are my new source updated coordinate. Now all things will be remain same because my destination coordinate will not change. Okay, if this is 1 means I found in some our loop I found any x which is equal to dash x and any y which is equal to dash y, then it will return 1. Then if this is return 1, then I will return 1, else I just continue for all 4 direction, and at last I will return 0. Return 0 means I don't found any path, because if I had found any, because it means if I found any, then I already return it from here, because I write a return 1 condition here, and because this for loop run completely means I am not able to found a path, so I just return 0. So I am now just running and compiling. You can see 0 0 means I have not found any path. Now I try to submit it. So you guys can see all the 10 test cases pass out. So I hope you will understand it. This is a big problem but not so much complex, because you just have to take care of 2-3 different things. Mainly is valid coordinate should be, g should uh, mainly second g should be not is equal to 0, and dp temp is not reverse yet. Okay, so I hope you will understand this, and if you have any doubt then just comment out. I will try my best to explain you. Meanwhile, you can subscribe the channel and like the video and check out my channel for more these type of videos. Thank you for watching this, guys.